Welcome back to another week. We are doing something sort of fun today. Well, I think so, so that means you probably don't agree. We are factoring expressions. Feel free to pause the video whenever you want to take notes. So we are doing the opposite of the distributive property. We are going to take a little bit of time exploring how to manipulate some operations of addition, multiplication, and division. And these skills are going to be used to help us solve equations and understand how the solving of equations works. So we have two goals. Number one, find the greatest common factor of expressions. This is pretty simple, but necessary. Goal two, write sums and expressions as products as factors. So these will be the new steps that we're taking, but after you practice some or understand how we can manipulate the numbers, I don't think you'll have too tough of a time. Okay, so we're going to break apart some basic multiplication problems. We're going to look at repeated addition as well. So when we have something like 7 times 8, we are looking at this as 7 groups of 8. But what we need to realize is that we can break this 7 apart into any pair or any set of numbers that we want. So if we wanted to break the 7 into 2 and 5, we can, because 2 plus 5 combined to equal 7. So if the 7 was being multiplied by 8, I could break this apart into 2 times 8 plus 5 times 8, because that would come out to be the same equation, or same answer, same expression. Now we notice that both of these are still being multiplied by 8, so both of these terms still have a factor of 8. Again, looking at repeated addition, which we know that multiplication is repeated addition. Here we have 5 6s. So we could think of this as, instead of 6 plus 6 plus 6 plus 6, 6 plus 6, we really just have 5 groups of 6, which I know you are aware of and familiar with, but as we move on to some more complicated problems, it can be very useful. This can work backwards. We see that we have 12 times 5 plus 8 times 5. And in your brain, we know we could do, okay, well, 60 plus 40. But we're actually going to look at it in a different way today. We're looking at the fact that they are both being multiplied by 5. And by both, I mean the 12 and the 8. So we can combine the 12 and the 8 to translate that to 20 groups of 5. So that was just the opposite of what we did on the very first example. We split the 7 into 5 and 2, and I just randomly chose the 5 and 2. Here, they're already split for you as the 12 and 8. For this example, we have 16x plus 24, and we need to be able to factor this out. So we're going to split this, and I know that 16 and 24 can both be divided by 8. So I'm going to factor out an 8. So I am dividing both 16x and 24 by 8. So 16x divided by 8 is 2x, and 24 divided by 8 is 3. So instead of saying we have 16x plus 24, we can write that as 8 groups of 2x plus 3, because that is the most simplified factored form. And then we have this where we have x plus 3 plus x plus 3 plus x plus 3, and this is repeated addition. So there are 3 of these. So instead of writing a bunch of addition, we can say, well, there are 3 groups of x plus 3. And these are all just different ways that we can manipulate expressions and equations, and you will be using all of these strategies eventually, but we're just practicing factoring today. So there are 2 types of problems on your homework assignment. We're going to walk through some examples. The first type says write each expression as a product of 2 factors. So we have 4 times 5 plus 11 times 4. So what we want to notice is that these are both being multiplied by 4. So that is a factor that we can factor out. So we are going to factor out a 4, and they are both being multiplied by 5 plus 11. So we can say that 4 groups of 5 plus 11. Number 2, this is repeated addition. We have 11 plus 5s all throughout, and there are 4 of them. So again, we can say, okay, well, there are 4 groups of, and I'm going to switch the order to make it the same, 5 plus 11. So I've taken repeated addition, and I have made it into factored multiplication. And number 3, this one is a little more complicated. So I have an 11 plus 5 in the middle, and I have 2 multiplication problems on the outside. So what we want to focus on are these 2 multiplication problems. I can see that both of them are being multiplied by 3. So I can say, well, that is 3 groups of 5 plus 11 plus, in here in parentheses, 5 plus 11. So this is from the middle. So I have 3 groups of 5 plus 11 plus 5 plus 11. Well, that makes 4. So again, for my third answer in a row, I have 4 groups of 5 plus 11. So those are 3 different problems that all factor out to 5 plus 11. And when the examples say to write each expression as a product of 2 factors, that means we want to have a multiplication problem where, in this case, we're doing 4 times 5 plus 11. Eventually, if we were solving this, we would certainly make it 4 times 16, but as we are just factoring, we are keeping it with the simple numbers. These next examples are a little bit simpler, and they are going to be really useful when we get to some more complex equations. For these problems, whether there are 2 terms or 3 terms or however many, all you need to do is figure out the greatest common factor and divide everything by the greatest common factor. So for number 4, when we have 40y plus 16, we are going to factor out an 8, and this is going to be the opposite of the distributive property. So 40y divided by 8 is 5y, and 16 divided by 8 is 2. So I have factored out the 8, and I'm doing 8 groups of 5y plus 2. If you're ever not sure if your answer is correct, all we would have to do is multiply using the distributive property, and we would end up at our original question. For number 5, we're going to factor out a 5. So that means we're dividing everything by 5. 50x divided by 5 is 10x plus 5y plus 3. So it doesn't really make a difference how many terms we have, but we want to find the greatest common factor of all of the sets. And number 6, 18a plus 27b minus 6. Well, I'm going to divide everything by 3, and I have 6a plus 9b minus 2, and I have factored that out. If you are ever doing a problem, let's just say you're doing 8x plus 12, that's not a 12, 8x plus 12, and if you're not sure how to come to or find the greatest common factor, we are going to, let's say, divide by 2, and we end up with 4x plus 6. If you realize that the 4 and the 6 can still be divided more, that means you are going to need to divide again or find the greater factor. So in this case, we could divide by 2 again, but we aren't going to divide this 2 by 2. We are going to actually have to multiply this by 2 because what we're actually doing is dividing by 4. So if you realize that you could factor by a bigger number, you can either just restart or you can divide both of these by 2, but the numbers on the outside are going to get multiplied. Which I know is a little complicated, but hopefully you don't have that issue or mistake. Okay, good luck.